All right, good morning. So I think what we're going to do today, first, let's talk about what we're going to do this week. So this week we're going to talk about what's called the quadratic formula. All right, so quadratic formula is going to eventually kind of be like our fail-safe, right? Like what happens when all else fails. In other words, either we can't factor in some cases, or we don't want to factor. We don't maybe love completing the square in general, or even if you do, if the coefficient of x squared is not a perfect square, that's not going to make a whole lot of sense to do completing the square. And some of us are going to use quadratic formula all the time. In other words, if you don't like to factor, quadratic formula will always work. So let's get away from that for a second. Let's complete this do now, right? So I know it's been a while. We had over the weekend. Hopefully we didn't forget what we learned about completing the square. So we're going to do this one completing the square, and then we'll shift gears to quadratic formula. So we said, what do I want this constant to be? We said we take the coefficient of x divided by 2, and then we square that. So we want it to be a 9. So this should be pretty easy then. If I have a 7 and I need to make it a 9, all I need to do is add 7 on, if I had a 2, I'm getting ahead of myself, and I want to make it a 9, I add 7 on both sides. So I've got x squared minus 6x plus 9 is equal to 7. So now I'm going to factor this as the quantity x minus 3 squared is equal to 7. Now we're going to take the square root of both sides. So I get x minus 3 is equal to plus minus radical 7. I'm going to add that 3 on both sides. And we said we can leave our solution like this, right? X is equal to 3 plus or minus radical 7. And if somebody said, well, it's a word problem, we need decimal answers, we put 3 plus radical 7 and 3 minus radical 7 in our calculator. But for the sake of what we're doing, this is fine. Okay, now let's think about what we just did. All right, so this equation, right, this expression of x squared minus 6x plus 2 is not factorable. Okay, there's no factors of 2 that add up to negative 6, which is why our answers end up being radicals. So we basically have two choices, right? Graphing is not going to help us. If I try to graph this, I'm going to get some, I'm going to see it touch the x-axis, but I'm not going to know that it's 3 plus radical 7 and 3 minus radical 7. So we basically have two choices, right? One choice is completing the square, which we just did, and the other choice is using what's called the quadratic formula. And again, the quadratic formula is very useful because completing the square is not always going to be easy, right? In other words, if this negative 6 was a negative 5, this becomes really difficult. And if on top of that you have something like this, completing the square is going to be very, very difficult. Not impossible, but it's going to be more effort than it's worth, whereas the quadratic formula is going to be really easy. So basically the quadratic formula is just kind of an application of completing the square. Okay, so here it is, right? So everyone, I'm not going to say those of us that are taking notes, because I know everyone's taking notes, everyone's putting this in their notes, right? The quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac, and that whole expression, and that's very important because sometimes we end up just cutting it off there, the whole expression is divided by 2a. So obviously it's a very popular formula. You see this lady or gentleman has it tattooed on his or her neck, and you got some really nice graffiti here with the quadratic formula, even though this person really didn't understand that aspect of the quadratic formula. We'll let them slide on that. But so this is a quadratic formula where a is the coefficient of x squared, b is the coefficient of x, and c is going to be our constant. And again, you can solve any quadratic equation like this without factoring and without having to use completing the square. So if you remember last week, I told you guys, and very honestly, I never learned completing the square when I was in school. I learned it when I started teaching math, and as a valid way of solving quadratics, but not one that's really necessary if you know the quadratic formula. So what we're going to do today is we're going to use the quadratic formula to solve factorable equations. Now, in general, I would, practically myself, I wouldn't do this. In other words, if I was solving this equation in front of me, I would factor it as x plus 7 times x minus 2, and I would solve the equations and I'd get negative 7 and positive 2, but I'm kind of trying to take this really slow. So we're going to spend today talking about factorable quadratics. We're going to spend tomorrow talking about maybe getting into some non-factorable ones, and then we'll talk about moving terms, and then we'll talk even about if we want decimal representations. So the first thing I'm going to do, I've got my quadratic formula down here, is I'm going to identify a, b, and c. If we don't know a, b, and c, the formula is kind of useless. So a is the coefficient of x squared, which in this case is 1. B is the coefficient of x. which is 5. And c is the constant, which is negative 14. Now, we really have to be careful with our order of operations, okay? In other words, you should end up in the end really with only two numbers. You're going to have whatever b is squared, and you're going to have negative 4 times a times c. That's going to give you one number. That number can either be positive or negative, but it's going to be one number, and then we're going to take b squared and either add or subtract it, okay? And again, if we can't follow order of operations, having the formula is going to be kind of useless. So I'm going to say negative b is negative 5, right, because that's what b is right here, plus or minus square root of, now b is 5, everything needs to go in parentheses here, 5 squared, negative 4, so I know it's really minus, but if we emphasize that it's negative, you're not really subtracting, you're multiplying, negative 4 times a times c, and the sign of the number becomes the operation symbol. Negative 4 times a, which is 1, times c, which is negative 14. And this whole expression, again, not like the graffiti, this whole expression, more like the tattoo, is going to be divided by 2 times a, which oftentimes is 1, but not always. So let's see what this looks like. So I'm going to bring down my negative 5, plus minus. 5 squared is 25. Now, again, guys, I'm doing this entire multiplication in one shot. Negative 4 times 1 is negative 4, times negative 14 is positive 56. So again, you should only have two terms in your radical. You should have the b term squared, and then you should have an operation symbol. And again, that operation symbol is the sign of the product of those three terms, the 4ac, and that's it. All right? And then it's divided by 2 times 1, which is 2. So now I've got negative 5 plus or minus the square root of 25 plus 56 is 81, divided by 2. Now I've got negative 5 plus or minus, well, I know the square root of 81, and it's 9. And you know what, I'm realizing that I was being kind of lazy here, guys. I forgot the x equals part, right? Because that's what the formula says. We're trying to find out what x is equal to. All right, so now what I'm going to do, and this will get easier actually when the answers are irrational, I'm going to split it up. So my solution right now is negative 5 plus or minus 9 divided by 2, which means one solution, and I'll bring it over here, is x is equal to negative 5 plus 9, and that whole expression divided by 2. And the other one is going to be negative 5 minus 9 divided by 2. So negative 5 plus 9 is 4, divided by 2 is 2. And negative 5 minus 9 is negative 14, divided by 2 is negative 7. So finally, after all of this, right, my solutions, I'll put it over here as a solution set, is negative 7 and 2. And again, guys, you're going to say, well, wouldn't it be much easier just to factor it? And of course, the answer is yeah, it would be easier for us to factor it. Which but the point of this is to be able to slowly kind of build up to the point where when we have things that are non-factorable, we'll be able to apply this as well. All right, so we've got x squared plus 6x plus 9. So I'm going to quickly go through a is equal to 1, b is equal to 6, c is equal to 9. And now I'm going to jump to my formula. So my formula says x is equal to negative b, which is 6, plus or minus the square root of 6 squared minus 4 times 1 times 9. And we said that whole thing is divided by 2 times a, which is 1. So now I get x is equal to negative 6 plus or minus the square root of 36 minus, and again, negative 4 times 1 is negative 4 times 9 is negative 36. Okay, so I was kind of jumping the gun a little bit because I knew what was going to happen, but that's where the negative comes from. Again, you're multiplying this by this by this, and whatever the sign is, if it's positive, this sign here is going to be a plus, and if it's negative, as we see here, then it's going to be a minus. And this is all divided by 2 times 1, which is 2. So what happens here? Negative 6 plus or minus the square root of well, I mean 36 minus 36 is 0. So I get x is equal to negative 6 plus or minus 0 over 2. Well, this is going to be kind of silly. I'm not going to set up negative 6 plus 0 and negative 6 minus 0 because they're the same. So this just becomes x is equal to negative 6 divided by 2, which means x is equal to negative 3. This is a perfect square trinomial. If I get back to this, how would I factor this? X plus 3 times x plus 3. So I only have to solve the, or I could do this using square roots. Think about day 2 of completing the square last week. I could do this as x plus 3 squared is equal to 0. The square root of 0 is 0, so x is negative 3. So we have a perfect square trinomial. So I wanted to illustrate what happens if you end up with 0 inside the radical. You only end up with one solution. Now, I don't usually do this, but I added it this year because a lot of you guys were struggling with these equations. And when I gave that quiz a couple weeks ago, a lot of us got these questions wrong. We were doing all sorts of crazy things, trying to use difference of squares. We're supposed to factor out the GCF, which is 3x, and then we get two solutions. One is 0, and one I think is going to be 6. I'm sorry, 2. So let's see what this is going to look like here using quadratic formula. So I get a is equal to 3, right? That's the coefficient of x squared. I get b is equal to negative 6, and I get c is equal to 0, right? There's no constant, so my c is going to be 0. All right, so now when we go to use the quadratic formula, we get x is equal to negative 6. So we have to be very careful with those parentheses, right? We have negative 6 plus or minus square root of, in parentheses, negative 6 squared minus 4 times 3 times 0 divided by 2 times a, which is 3. So now I've got x is equal to negative 6 is positive 6 plus or minus. Now negative 6 squared is 36. Make sure the parentheses are there. I know a lot of you are going to use your calculators. You're going to forget the parentheses, and your calculator is going to give you negative 36, which is right without parentheses, but that's not what we wanted to do. So we have 36, and then it's negative 4 times 3 is negative 12 times 0 is 0. So I don't need to put plus 0 or minus 0. I'm just going to leave that exactly as is, and I'm going to put this whole thing divided by 2 times 3, which is 6. So now I get 6 plus or minus, well, the square root of 36 is 6, divided by 6. So now I'm going to bring it over here, and I'm going to split it. I'm going to say one solution is x is equal to 6 plus 6, divide 6. And one is that x is equal to 6 minus 6, divide 6. So 6 plus 6 is 12, divided by 6 is 2. And 6 minus 6 is 0, divided by 6 is 0. So one solution is 0, and one solution is 2, which is the same thing we get if we factored out, just to quickly do this the way we would have done it before quadratic formula. We would have done this, hopefully. And again, a lot of us had problems with this. And we get x is 0, and we get x is 2. So again, we get the same solutions. It's the same equation. But a lot of us were not able to do this. Everyone can use substitution, especially considering you have a calculator. All right, so this is where the quadratic formula will be very helpful for a lot of us, right? So coefficient of x squared is not 1. So a lot of us, when we were back in school, we were all masters of the 5-step method. Since then, kind of fallen off the tracks a little bit. A lot of us forget to bring back the coefficient at the end. We forget to divide it out. And I've been putting comments and notes and stuff on your homework, and it's fine. I understand that. But now we don't really have to worry about that anymore with quadratic formula. So I'm going to say that a is 2, and b is negative 9, and c is negative 35. So now I'm going to go to my quadratic formula. X equals negative 9, plus or minus the square root of b, which is negative 9 squared, minus 4 times a, which is 2, times c, which is negative 35. And that's all going to be divided by 2 times a, which is 2. So I've got x is equal to negative 9, which is positive 9, plus or minus square root of negative 9 squared is going to be 81. Negative 4 times 2 is negative 8. Negative 8 times negative 35 is going to be 280. And 2 times 2 in the denominator is 4. So So now I'm looking at 9 plus or minus radical 361, all divided by 4. Square root of 361 is 19. 9 plus minus 19 divide 4. So I'll bring it over here and I'm going to split it. So now I've got x is equal to 9 plus 19 divide 4. And I've got x is equal to 9 minus 19 divide 4. So 9 plus 19 is 28 divided 4 is 7. And 9 minus 19 is negative 10 divided 4 is negative 5 halves, or if you want to use a decimal, negative 2.5. So I'm going to say negative 5 halves and 7. And again, this is the same thing you'd get if you used 5-step method, but a lot of us, like I said, have really struggled with the 5-step method. This basically, eliminates almost the need to factor, not in general, but as far as solving a quadratic equation, you can use this literally for every single quadratic you ever do, unless you're being required or forced to graph. All right, so I do want to make sure you guys are doing the now try, right? So, and make sure, like I mentioned to a few of the classes, there may be some notebook checks coming up. So make sure you guys are taking some good notes. So for this first one, I've got x equals negative 2 plus minus the square root of 2 squared minus 4 times a, which is 1, times c, which is negative 15. And that's all divided by 2 times 1. So I've got x equals negative 2 plus minus the square root of 4. Negative 4 times 1 times negative 15 is positive 60. And that's all being divided by 2. I've got x equals negative 2 plus minus the square root of 64. X equals negative 2 plus minus the square root of 64 is 8 divided by 2. So I'll split it up over here. So I've got negative 2 plus 8. And I've got negative 2 minus 8. So here it becomes negative 2 plus 8, which is 6, divided 2 is 3. Here it's negative 2 minus 8, which is negative 10 divided 2, which is negative 5. So my root should be negative 5 and positive 3. And again, if you were to go back and factor it from the beginning, right, you get x plus 5 times x minus 3, which would give negative 5 and positive 3. So we're going to get the same results, the same answers, but we're going to get them in a way that, even though if you look at it, it looks like certainly it's a lot more steps, but it requires less thinking. It doesn't require any thinking, right, especially with number 2. A lot of us, if we're trying to do 5-step method, are going to make mistakes here. Really, no one should be making mistakes with quadratic formula. It's just substitution, right? So I've got x equals negative b, which is negative 9, plus minus the square root of negative 9 squared, minus 4 times 2 times 7. And that's all going to be divided by 2 times a, which is 2. So negative 9, or really the opposite of negative 9 is positive 9. Plus or minus negative 9 squared, which is 81. Negative 4 times 2 is negative 8 times 7 is negative 56. And that's all going to be divided by 2 times 2, which is 4. So 81 minus 56 is 25. Square root of 25 is 5. So I get 9 plus minus 5 divide 4, so I will bring it over here to split. So I've got x equals 9 plus 5 divide 4. I've got x equals 9 minus 5 divide 4. So here I've got x is equal to 14 fourths, which I can simplify if I'd like as 7 halves. And here I've got x is equal to 4 fourths, which is 1. So my solution set should be positive 1 and positive 7 halves. And again, this is an alternative to having to use the 5-step method or trial and error, or whatever other method we were using. So make sure you guys are, continue to be taking notes in class, and make sure you're showing all the steps with the homework and that we're using quadratic formula and not factoring or completing the square.